In this video, we're going to be learning about a number called the natural base e, and we're going to then be learning how to simplify expressions that contain the value of e. So the natural base e is a special number that's used in math when we talk about concepts of exponentials and logarithms, and this chapter is actually based on logarithms, which is why we need to be aware of the natural base e. Now, what I'd like you to think about this number as is it's a special math number that is used because it appears over and over and over again when dealing with a particular concept. So you've already learned about two special math numbers in your past that you use now regularly. One of them that you already are aware of is pi. You used pi when you took geometry, and pi is really a special ratio that is circumference divided by diameter for any circle. And you know that pi is approximately 3.14159, so on and so forth. It's an irrational number that goes on forever that represents that very specific ratio. The other math number or special math number that you're used to is the special math number of I, which is equal to the square root of -1. And we used that when we had square roots of negative numbers so that we could simplify them and they represented a specific number. So we've already learned about special math numbers in our past, and e is just another one of those special math numbers. Now the natural base e is essentially calculated as we look at a very special expression. So if we look at the expression of 1 plus 1 over x to the power of x. You'll notice this kind of looks like that compound interest equation. It's a little bit different, but it's pretty similar. So when we look at this particular equation here, basically saying we're starting at 1 and we're adding 1 over x to that 1, and then we're going to take it to the power of x. And when we take that expression and we look at what happens on a graph as x approaches infinity, so basically what that means, as x gets bigger and bigger and bigger and bigger and bigger, what happens on this graph is the graph looks something like this. So it kind of shoots up through here at 1, and it shoots that way. And it gets really, 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 really close to this number. This number that it's getting really, 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 really close to is our natural base e. So that's where the natural base e comes from. And the natural base e is approximately 2.71828182, etc. So what you really need to know about e is that it comes from this expression, and as that expression approaches x equals infinity or goes very, very far to the right, e is the number that that expression approaches, and it's approximately 2.71. So we're going to be using this value as we work in this chapter. Now, the other thing that you need to be aware of is you need to be able to find it on your calculator, which is sometimes a little bit tricky. Now, the natural base e often pairs with what are called a natural logarithm, and we're going to learn about logarithms later in this chapter. And so to find e on your calculator, typically what you do is you look for the natural log button, which is typically the LN button of sorts on your calculator. And if you look, e is typically paired with it, but it looks like it's above it, and you'll see e to the power of x. That's because we're typically always taking e to a power. And from there, when you look at that, what you'll notice is that in order to access it, you simply pressed second, and then you typically press the LN button to access e. So if you can't find that on your calculator, please ask for help finding it, as you'll need to be able to access it throughout this lesson. Now, because e deals with expressions that typically contain exponents, we need to be able to simplify expressions that contain e. Now, what's really nice is we've already learned about expressions that contain exponents, and now we're just looking at specifically expressions that contain e. So we're just going to recap our exponent properties and make sure that we can simplify expressions that contain e so we can then work with e in the future. So here, what you're going to notice is we have e to the power of 3 times e to the power of 6. So this is very, very similar to what we've seen in the past. And what we're noticing here is we have the same base, which is e. And when we have the same base and they're simply being multiplied, we add our exponents. So this is what we've done in the past with other types of expressions that contained numbers or variables, but now we're utilizing e. So here, if we have the same base, which is e, and they're being multiplied, we simply add their exponents. So this would become e to the power of 9. So that's the first exponent property that you need to be aware of. Now the second expression here uses division. So again, we notice that we have the same base. You can see the same base of e, but they're being divided this time instead. So where we're adding together the expressions when we have the same base and we're multiplying, when we have the same base and we're dividing, we're going to subtract those exponents. Now what you need to remember about this is you have to know if e is going to end up in the numerator of the fraction or the denominator of the fraction. So you typically subtract those exponents when you have a common base being divided, and then the remaining go wherever the larger number was, which in this case is e to the 5th. So from here, in order to simplify this expression, we take e to the 5th minus 4, which is going to be e to the 1st, and because 5 was larger, e to the 1st ends up in your numerator. Then from here, we also have to simplify the just numbers part of this expression, and this works just like normal simplifying fractions. So we have to remember how numbers work differently than exponents with common bases. And when we're simplifying fractions, we just need to find a number that they're both divisible by. Well, both are divisible by 4. 16 divided by 4 is going to be a 4 in your numerator, and then there's going to be a 1 in your denominator. Now, because you have a 1 in your denominator, you can simplify that to be just 4e to the power of 1. Now, this last one here looks a little bit different. What you notice is that you have powers raised to power. So you'll notice we have that power on the outside of that set of parentheses. So when we have powers raised to powers, we actually need to multiply the powers. So we noticed common bases being multiplied, we would add our exponents. Common bases being divided, we would subtract our exponents. And now when we have a situation where we have powers raised to powers, you have to multiply the powers. Now, what you also need to remember is that 3 here also has a power of 1. So not only do you multiply the 2 times the negative 4x, but you also multiply the 2 times the power of 1 that belongs to the 3. So here, if we use our powers to powers and we multiply our powers, we end up with 3 to the power of 3 times e to the power of negative 8x. Now from here, we have a little bit of simplifying that we need to do. So we can see that we have 3 to the power of 3, which we know is 3 times 3 times 3, which is 27. So we have 27e to the power of negative 8x. Now, if I said that I wanted this to have positive exponents only, which you should be able to create and work with, so this is what it looks like with negative exponents. Remember, with positive exponents, we can put the entire fraction over 1, and we can move the item that contains the negative exponent down into your denominator. So we can simplify this a little bit further by moving the e into the denominator, so it will become 27e to the power of 8x. So exponent properties work the exact same with e, and we're going to focus on simplifying expressions that contain e in this lesson.